Let R be the region bounded by y equals natural log of x, the x-axis, and the line x equal 3. Find the volume of the solid that is generated when the region R is revolved around the x-axis. So let's go ahead and draw a sketch so we can see what our region R looks like. And our natural log graph at 1 is 0, so it looks something like this. And then we're going to look at the x-axis and the line x equal 3. So here is our region R. We're rotating this around the x-axis. So we can see if we did that, we could use the disk method and have a little thickness here, dx. And so if we integrated from 1 to 3, we'd have our disk area would be pi r squared, so that's going to be pi. Our r is the y value here, which is the natural log of x. So natural log of x squared, and then multiplied by our little thickness, dx. Now in looking to integrate this, at first glance it might look like a u substitution, letting u be natural log of x. But if we did that, our du would be 1 over x dx, and you can see we do not have that function of x here. So instead we are going to use an integration by parts. We're going to go ahead and put this pi out in front, and we're going to call this part u and this part dv. So u is natural log of x squared, which means du, we could do a power rule, chain rule. Power out in front, decrease the power by 1 multiplied by the derivative of what's inside, and what's inside's derivative, natural log of x, is 1 over x, and then dx. Now our dv was dx, so that means our v is going to be x. So dv was dx. Okay, so we have pi, and then multiplied by uv, so that's going to be x natural log of x squared, and that's evaluated from 1 to 3, minus the integral from 1 to 3 of v, that's x, du. So that's 2 natural log of x, 1 over x dx. And we can see that this function of x, these will cancel. And so we are now left with this integral to compute the integral of natural log of x dx, because we could move the 2 out in front. Now we did that, we derived that, but down the road you may not remember what that is, because only so many things to keep in your head. So let's go ahead and find that again with integration by parts. So we are going to move this 2 out of the way, and we're going to call this u, and we're going to call this dv. So our u is natural log of x, which means our du is 1 over x dx. And our dv is dx, which means our v is x. So this will equal pi multiplied by x times the natural log of x squared. And then we have minus 2 times uv here, which is going to be x natural log of x, minus the integral, and let's go ahead and make, let's see, this piece will be evaluated from 1 to 3. I don't have the notation quite right because I have this negative 2 here. And 1 to 3 of what is left here, let's see, it's v, that's x du, which is 1 over x dx. So we can see that these will cancel, and we can go ahead and perform that last integral, and then we'll do our evaluation. So pi times x times the natural log of x squared minus 2x natural log of x plus 2x evaluated from 1 to 3. So this negative 2 applies here, and then this is just simply the integral of dx, which is x. Now if we evaluate that, we have our upper limit 3 natural log of 3 squared, minus, putting a 3 here, we have 6 natural log of 3 plus 6, and then minus our lower limit, but we have the natural log of 1, which is 0, And then the second term here we have natural log of 1 again. So the only thing we will have here is the 2, and we put a 1 in right here. So our final answer in exact form will simply be pi multiplied by 3 times the natural log of 3 squared minus 6 times the natural log of 3 plus 4.